We're working in section 3.1. We're graphing quadratic functions. So far, the functions we've looked at were in vertex form. And now here in example 3, we have a function that's given to us in standard form. The big question is, how could we find the vertex now? There are actually two ways we're going to do this. Method number one is to convert from standard form to vertex form. And the technique to do this is something we've studied earlier in the class, and it's called completing the square. In chapter 1, we learned how to solve a quadratic equation by completing the square. And in chapter 2, we learned how to find the center and radius of a circle by completing the square. So here is the same idea again in a new context. So completing the square is a pretty important idea for us this semester. Let's run through it. Let's start with y equals x squared minus 4x, and then let's leave a little space and then write the minus 2 after that. Remember, when we complete the square, we take the x squared term and the x term together, and then we figure out what is the constant term that will make the perfect square trinomial. So the minus 2 is not going to help us. The x squared and the minus 4x have to stay together. When the coefficient on x squared is 1, and when the coefficient on x squared is 1, then we just look at the coefficient on x, that's minus 4, and we do a little calculation. We can come out to the side and we can write 1/2 of minus 4 is minus 2, and then square the minus 2 to make positive 4. And so 4, that positive 4 is what we need to add on to complete the square on x. So let's go ahead and add 4. Let's see. What we learned before is if we add 4 to one side, then we need to add 4 to the other side as well. We could go ahead and add 4 on the left side and have y plus 4. But we wouldn't want to leave it like that. We're trying to write a function, and so we want to just have y alone on the left side. If we had y plus 4 on the left side, we would subtract that 4 from both sides in order to move it back to the right. So let's just go ahead and subtract it right now on the right side, and then it never has to be on the left side. And now look at what we've got. Look at our new formula, and you see the plus 4 and the minus 4 would cancel each other out, and so the new formula is equivalent to the formula we were given. So all this looks pretty good. And so we're going to take the x squared minus 4x plus 4, and we're going to factor that perfect square trinomial. The factors are x minus 2 times itself. So we can go ahead and write y equals x minus 2 squared, and then minus 2 minus 4 is minus 6. And sure enough, that's vertex form. That's vertex form. And so where's the vertex? Well, we get the x coordinate right after the x. We have a minus 2. Remember, we need to flip the sign on that minus 2 and call it a plus 2. And then the constant at the end, the minus 6, is the y coordinate of the vertex. So we have a vertex at 2, negative 6. Okay, that's good math. Let me show you another way to do it. I guess the second method is a little bit easier because it's just a formula. And if we can just remember the formula, then it's not too difficult to plug in. So the formula says that if we're given standard form, right, standard form is ax squared plus bx plus c. From standard form, the x coordinate of the vertex is given by x equals negative b over 2a. So that formula might seem a little mysterious. Actually, I'll make an extra video and I'll show you where that formula comes from. It actually might remind you of the quadratic formula, which starts out with a negative b in the numerator and the denominator is 2a. So that's a hint for you. For right now, for our purposes, we just need to memorize the formula and be able to use it. So in our example number 3, what is the value of b? B is negative 4, so we'll have negative 4 divided by 2 times a, and a is the coefficient on x squared, it's 1. And so we have 4 divided by 2, which is 2. And of course that's the x coordinate of the vertex. That we already know that's the correct answer because we already found the vertex by the first method. How would you get the y coordinate? Well, the y coordinate is the y that goes with x equal 2. So all we need to do is just plug in x equals 2. Plug in x equals 2. And we'll get y equals 2 squared minus 4 times 2 minus 2. And that's 4 minus 8 is negative 4, minus 2 is negative 6. So x equals 2, y equals negative 6. We can write the same answer again. We got the same answer by each method. Think about which method you like better and practice both of them. Completing the square is an important idea. Okay, so let's go ahead and finish the graph now for example number 3. So let me scroll down here a little bit and get some space on the page, and let me rewrite the function that we're talking about here so we don't forget it. It's x squared minus 4x minus 2. We know where the vertex is. Do you remember what else we'd like to know before we sketch the graph? It's the intercepts. The y-intercept and the x-intercepts will help us finish the graph. To get the y-intercept, we set x equal to 0. We have y equals 0 squared minus 4 times 0 minus 2, which is negative 2. I suppose I should have written that in blue. Here I'll write the answer in blue. The x coordinate is 0 and the y coordinate is negative 2. To find the x-intercepts, we're going to set the function equal to 0. We'll have x squared minus 4x minus 2 equals 0. How do we solve that quadratic? Usually we start by trying to factor. This function, this equation doesn't factor. So what do we fall back to? We fall back to the quadratic formula. We have x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. We need to simplify that. Underneath the radical, we have 16 plus 8 is 24 over 2. Square root of 24 is what? Perfect square factor is 4. Square root of 4 is 2. And there's a 6 left over. And then we can cancel out the 2 in the denominator with a factor of 2 out of each term in the numerator. So 4 divided by 2 is 2. And then the 2 root 6 divided by 2 is just root 6. So those are good answers. Now, if we're going to graph this thing, we probably ought to figure out a decimal approximation for these two x-intercepts. So let's keep going here. One more step. Let's do 2 plus root 6 on the calculator is going to be 4.4 approximately. And so we can write the ordered pair 4.4 comma 0. And then 2 minus root 6 is going to be negative 0.4, and we can write that ordered pair as well. Okay, I guess we have everything to go ahead and sketch the graph. Let's go ahead and start with the vertex at 2, negative 6. From the origin, I'll go over 2 to the right and then down 6. There's my vertex. I better go ahead and get a scale. We always like to make sure we have a scale on every graph. The y-intercept is at negative 2. And then the x-intercepts we found at 4.4. So just about halfway between 4 and 5. And then just about halfway between 0 and negative 1 would be the other x-intercept at negative 0.4. Let's see, we didn't write down the axis of symmetry. It would be the vertical line at x equals 2. And that might help us to reflect the y-intercept over to the other side of the graph to give us one more point. So the point at 0, negative 2 would reflect over to 4, negative 2. And then we can connect these points up with a nice smooth curve. And there we have it.